Hello everyone, how are you? And welcome back to Math Zone African Motives. We are still on our revisions for our November examinations. So today I brought you a question paper from KwaZulu-Natal province. It was a question paper for grade 11s and it was a physical sciences paper 1, which is the physics section paper that was written in November 2024. As you can see, it was written as the final examination, which is the end of year examinations, and it was out of 150 marks. So I want us to use this question paper for our revisions. So this question paper was carrying 10 multiple choice questions, and then it was also having 7 open-ended questions. So we are going to do the multiple choice questions first, and then we are going to do the structured questions later. So as always, we would be given 4 options for our multiple choice questions, which is either option A, B, C, or D. And out of those 4 options, you always have one correct answer. So without wasting time, let's get to see how the question was structured. So for question number 1.1, they were saying which one of the following pairs can be classified as scalar quantities. So for scalar quantities, we know that these quantities, they have got magnitude only. So which of the pairs that are given here consist of magnitude only? Which of them can only be fully described by stating its size only? That is what they mean. So option A was saying mass and inertia. Yes, mass and inertia, they can both be fully described by stating their sizes only. Inertia, but weight is not. So weight is a vector quantity. Weight and frictional force are all vector quantities. Frictional force and mass, this one is a vector quantity. This one is a scalar quantity. So they want where we have got a pair of what? Scalar quantities. So our correct answer was going to be A. For 1.2, they are now saying the vertical component of a force acting on an object which is moving horizontally. So we have got an object that is moving horizontally, let's say maybe in that direction, and then we would now have a vertical component of a force like that. Now they are asking us, or else you would be having an object that is moving horizontally, and you have got an inclined force. So within this inclined force, you would have a vertical component of the force, and then you would have a horizontal component of the force. Now they are asking us, is the vertical component of the force that is acting on an object that is moving horizontally going to accelerate the object horizontally? No, it won't. Is it going to accelerate the object vertically? It is not going to be able to accelerate it vertically because the object is just moving what? Horizontal. So vertically there is no acceleration, so it won't. And then does it have a tendency to move the object vertically? Yes, it has got a tendency of moving the object what? Vertically, because its component is in the vertical what? Direction. Hence, therefore, you would end up having what? The spinning of the object. You would have up ending the spinning of the object, because we are saying there is a vertical component of the what? Of the force that is unbalanced that can actually cause that. So our correct answer there was going to be C. It was going, or else the vertical component of a force that is acting on an object that is moving horizontally, it has got a tendency of moving that object vertically. Now 1.3, a crate is moved from rest. This is the crate across a rough horizontal surface by a force F. So they're saying that this surface is rough. Which one of the following statements about the kinetic frictional force acting on the crate is possible? So we are concerned with what? Kinetic frictional force of the what? Of the object as the crate is moving. The kinetic frictional force is greater than the maximum static frictional force and less than the force. So what we know is for this object to move from rest, this force has to overcome what we call the static maximum frictional force. It has to overcome the static maximum frictional force. So this applied force would be greater than the static what? Frictional force. And once the object is now moving, this is where we will now start having what we call what? The kinetic frictional force. And this kinetic frictional force is actually what? Less than the static maximum frictional force. So at some point in time, the kinetic frictional force is less than the maximum static frictional force and less than the what? The applied force. So that is the option that we are looking for here. So the kinetic frictional force is going to be less than the static frictional force. And then it is also going to be less than the applied force. So our correct answer there was supposed to be D. 1.4. Consider the following statements related to Newton's third law. When a force acts on an object, when a force is acting on an object, this is the force that is acting on an object. Let's say this is Fa acting on object B. Is the force, now they're saying when the force acting on an object, is the reaction to this force going to act on the same object? Are we going to have a reaction to this force acting on this object? Is it going to be acting on that object? From the Newton's third law. So from the Newton's third law, he said that as long as we have got two objects, A and B, interacting with each other, A is going to exert a force, let's call it Fa, on B, which is going to be equal but in the opposite direction to a force that B is going to exert on A simultaneous. So the reaction force to A would be B, and the reaction force to A is going to act on a different object from what? From the one that force A is acting on. So this is actually what? Is actually force. So here they're saying the reaction to this force acts on a different object. This is true. The time for which the force acts is greater than the time for which the reaction to this force acts. So the reaction time in which these forces act, they are going to be the same. So this is force. The force and the reaction time to this force are in opposite direction. Yes, the force and the reaction force are opposite to this direction are what? Are opposite. So this is actually what? This is actually true. So that is 2 and 4. So our correct option there was going to be what? 1.4. That was going to be 1.4. Now let's do 1.5. 1.5 is saying the acceleration versus resultant force graphs for the motion of object X and Y are shown below. Which one of the following statement is true? So we are given the acceleration of an object X and Y against the resultant force, and these are the graphs. And they are now saying which of the following statements are true. Statement 1 is saying object X has a greater mass than Y. Object Y has a greater mass than X. If object experience the same acceleration, the resultant force on object X is greater than the one on object Y. For the same resultant force, object X has a smaller acceleration. So from this graph, which statement can we say it's true there? So one thing that we can take is there is Newton's second law, which says if a net force is applied to an object, the object will start to accelerate with an acceleration in the same direction as what? As the force applied. So F net is going to be ma, is going to be equal to ma, meaning to say that from this graph, we've got acceleration and net force. So our mass can be given by what? By net force all over the acceleration. So using this graph, we are going to have a gradient for these two graphs. So the gradient for x and the gradient for y. Now, gradient for x is actually what? Greater than gradient for y. The slopeness of x is actually what? Steeper than the slopeness of y. And then gradient of x is given by what? It is given by acceleration over net force, which is the same as what? So you can see that gradient here is the same as 1 over net force times acceleration, which is just 1 over what? The mass. So if it is gradient of x, it is 1 over mass of x. If it is gradient of y, 1 over mass of y. So here we are saying gradient of x is greater than gradient of y. And here we can see that the gradient is inversely proportional to the mass. Meaning to say that the larger or else the steeper the gradient, we are going to have the what? The smaller the mass. And then the smaller the gradient, the larger the mass. So here they're saying object X is a greater mass than object Y. This is not true because for object X, the graph here, the gradient is steep. So the gradient of X is steeper than the gradient of Y. Therefore, the mass of X would be less than the mass of Y. That is what you can actually get to predict there. So object Y is greater mass than object X. This is actually true. So our correct option was going to be what? Was going to be B there from those two graphs. Now let's go to question number 1.6. The magnitude of the gravitational acceleration on Earth is G. What would be the value of the gravitational acceleration B on planet X, which has the same mass as Earth but half the radius of Earth? So planet X has got the same mass as what? As the mass of the what? Of the Earth. But the only difference is on the what? On the radius. So we know that the gravitational acceleration is given by G mass over what? Over r squared, where this is the mass of the planet. So this is the mass of planet Earth. And we are now saying what would be gravitational acceleration on planet X, which is having G and the same mass as the mass of what? Of Earth. All over the radius is just half r of Earth squared. So this would actually get to give you 1 over 4 GME over r squared. So 1 over 1 over 4 of this. So this was going to be equal to 4 GME over r squared. Because here, this is 1 over 2 squared, it gives you 1 over 4. So it was going to be 4 GME r squared, which is simply 4G. So the gravitational acceleration on planet X is going to be 4 times the gravitational acceleration on what? On planet Earth. So our answer there was going to be B. Now 1.7, a small test charge Q is placed exactly halfway between two fixed identical charged spheres X and Y, each carrying a charge of Q as shown in the diagram below. The net electrostatic force experienced by the test charge would be, so the net electrostatic force experienced by that test charge is going to be equal to what? We can see that we have got equal magnitude in our what? In our charges. And since these, they've got the what? The same sign, they are going to act in the what? In the opposite direction. So their force on what? On test charge Q are always going to be what? In the opposite direction. But however, the forces are actually equal, but they are in opposite direction. Therefore, the net electrostatic force there is going to be zero because they are going to balance each other out. Now let's go to 1.8. Let's go to 1.8. The minimum resistance that can be obtained by connecting two 4-ohm resistors in a circuit is. The minimum resistance that can be obtained by connecting two 4-ohm resistors in a circuit is. So we have got 2 ohm resistors which can either be connected in series or else they can be connected in parallel. If that is the case, I would be having a 4 ohm resistor, 4 ohm resistor, 4 ohm resistor, 4 ohm resistor. So you would see that here resistance in series would actually be equal to what? 4 plus 4, that is 8 ohm. And then resistors in parallel, if we are having two resistors, we know that resistors in parallel is just equal to what? Product over what? Over sum. R1 times R2 all over R1 plus R2. So that would be 4 times 4 divided by 4 plus 4. That would actually give you 16 over 8. That is equal to 2. So you can see that the minimum in between these two is going to be 2 ohm. So our answer there was supposed to be equal to what? To D. Now, if our answer was going to be D there, let's go to question number 1.9. Now, the two resistors in circuit 1 below are identical. They are connected to a cell with EMF V and negligible internal resistance. So there is negligible internal resistance and the total EMF is V, and the power dissipated by each resistor is T. So the power dissipated within each resistor here, they are saying is equal to P. Now let's see what's following. The same resistors are now connected in parallel as shown in circuit 2. These are the parallel connections. Now they're saying, what is the power dissipated by each resistor in circuit 2? If power in circuit 1 is P. So this is where you now get to see that how do we relate voltage, current, and resistance in what? In parallel and in series. So the information that we are given here, it's about power. So we know that power is equal to voltage times current, or else voltage squared divided by resistance, or else current squared times resistance. So for circuit 1, we would call this power for circuit 1. They are saying that it is equal to what? It is equal to P. Where for each is equal to P. The dissipated power for each resistor is equal to what? To P. Now, you would see that here, this is a series circuit. The voltage actually splits into what? The voltage actually splits into two. So voltage that is on resistor R and the voltage that is on resistor R again. You add them, they will give you the total voltage. So V total would be equal to what? VR plus VR, which is equal to what? 2VR. That is what we know about a what? A series circuit. Now, if the total dissipated power is equal to P, it simply means that this is equal to what? VR squared. The voltage on each resistor divided by the resistance. So voltage on each resistor squared divided by the what? By the resistance. So VR squared over what? Over R. Now they're telling us that the same resistors are now connected in what? In parallel. So what would be the power dissipated in each now for circuit 2? So you will see that the power there will now be equal to what? The voltage that is across each resistor now, it is now equal to what? To this V total, because this is voltage in parallel. And we know that V total, we said it's equal to what? To 2VR. So here the power would be equal to what? It would be power in 2 would be given by 2VR, and then that bracket squared over what? Over R. That gives you 4V R squared over R. That is the same as what? 4P. Because we know that here VR squared over R is equal to P. So VR squared, 4VR squared over R had to be 4P. So the answer there was going to be B. That is how you would have determined that. Now, question number 1.10, it is now saying a bar magnet is moved into and out of a solenoid. Which one of the following changes will result in a larger induced EMF in the solenoid? So we know that what governs the induced EMF is the what? Is the Faraday's law, which says that the EMF induced is directly proportional to the what? to the rate of change of the what? Of the magnetic flux. So we would also get to know that the magnetic flux is equal to the magnetic field times the area of what? Of our armature times cos theta times cos theta. Now we are saying that the stronger the magnetic field, which is the stronger the magnet, the higher the what? The EMF induced. The bigger the area, which is the bigger the diameter of the coil, the higher the what? The higher or else the larger the EMF induced. And then the faster the rate of change, the higher the EMF induced. The higher the number of turns, the higher the EMF induced. So here they're saying we can increase this induced EMF by using a weaker magnet. This is actually incorrect. We need a stronger magnet here. We can increase by using a solenoid with fewer turns. No, it's not correct. We need more turns. Using a solenoid with a smaller diameter. No, we need a larger diameter to have a larger what? Cross-sectional area. Moving the magnet faster into and out of the solenoid. Yes, this increases the rate of change of what? Of magnetic flux. So our answer was going to be D. Now, let's go to question number 2.1. Question number 2.1 is now saying three coplanar forces, F1, F2, F3. Coplanar means that they are acting in the what? In the same plane. Of magnitude 6 newtons, 3 newtons, and 4 newtons, respectively, act on an object. The sketch below, not drawn to scale, shows the directions of the what? Of the forces. This is the sketch that has been given. And they're now saying define the resultant force. So you know that the resultant force is that single force that will have the same, is that single force that will have the same effect as the sum of the individual force. As the sum of the individual forces that are acting on the what? On the object. So is that single force that will have the same effect as the sum of the what? Of the individual forces acting on the same object. So that single force that would have the same effect as these three would become our resultant. Now they are saying calculate the magnitude of the resultant force acting on the object. So on this object, you can see that we have got forces that are acting on your y-axis. We have got forces that are acting on your what? On your x-axis. So we need to have a resultant on the x and a resultant on the y, so that the total resultant now can be given by what? Maybe let's say we can use at some point in time this right angle triangle, where we would be saying the resultant is actually the what? The hypotenuse. So that would be r squared is equals to what? Rx squared plus ry squared, where the direction would be given by that angle. So we now need to actually get to what? To resolve these into x and y forces. After resolving into x and y forces, then we can be able to what? To find our total resultant. So just allow me to wrap this now. So I would use this space here. So I'll start by my what? By my y forces. The resultant on the y would be given by F1 plus the vertical component of what? Of F3. So it will be F3 vertical component. And how do we find the vertical component of F3? You can see that F3 is acting on a slanted angle that is actually pointing downward. So this vertical component would be given by F3 sine theta. And that sine theta is 45. So here we can come and say, let's choose up to be positive. So up is what? Is positive. So I'll take 6 newtons plus I've got what? F3, that is 4. So maybe let me just get to just take 6 without saying 6 newtons. So 6 plus 4 sine 45. So by using our calculators or else from special angles, we know that this would be 6 plus 4 times root 2 of 2. That would be simply equal to 6. That being 6 plus this would be 2 root 2. And what becomes the answer there? If I say 6 plus 2 root 2, I'm going to get 8.828. 8.828. 8.828. That can be equal to 8.2. I'm still repeating the same mistake. 8.828 newtons. So that becomes the resultant in my y direction. So this is acting up. Why? Because it's a positive. We said going up is positive. Now let's determine our what? Our x resultant. That would be equal to what? To this force which is acting in that direction, that is F2, plus the horizontal component of this same force again. That would be what? The horizontal component would be given by F3 cos theta. So here I would come and say what? F3 horizontal component. So that would be equal to, taking going to the right to be positive, would actually get to say 3 plus, now I would be having what? 4 cos 45, which is simply also equal to 3 plus 4 bracket root 2 over 2. Using what? Using special angles there. That would give me 3 plus 2 root 2. And that becomes equal to what? 3 plus 2 root 2. That becomes 5.8. That becomes what? I think there is something that I'm making a mistake here. 5 point, that should be 5 point. Here I'm having these two going in the same direction, but here I was having these two going in the opposite direction. Do we agree there? Do we agree there? Yes, we should be agreeing at some point in time. Mean to say that this is actually correct, 8.28, but the one that is on top there, I just discovered that here we also added, while we're having what? Two forces going in opposite direction. So here I was supposed to say 6 minus that 4 sine of 45. Just pardon me there, I was supposed to subtract because this is actually going in the downward direction. And we said down is a what? It's a negative. So we would have just given it a negative there so that it becomes 6 minus 2 root 2. So I'm sure there we're supposed to get an answer of what? We're supposed to get an answer of 6 minus 2 root 2. It was going to give us 3.17. It was going to give us 3.17 newtons. So 3.171 newtons there. So those were the two resultant, the resultant in the y direction, the resultant in the x direction. Now we want the overall resultant, which we say that we calculate it by saying what? R squared is equal to what? Rx squared plus Ry squared. That is what we want to now get to look into. So if that is the case, just allow me to move this that side so that I can calculate my what? My resultant. So you would see that on a diagram, if you are representing this, you would see that the diagram would be in such a way to say this is actually what? Going up, and this is actually going in that direction. So on a diagram, you would be having 5.828 newtons going to the east, and then you would be having what? 3.171 newtons going up, so that your resultant would be going to the what? Northeast, so that this becomes its direction, and this would be our R. So using Pythagoras theorem, this is where we actually derive this formula from. So my R, I would say it is root of what? rx squared plus ry squared, so that it would be equal to, now I will just need what? To feed in my values there. So it was just going to be 5.828 squared plus 3.171 squared. So my resultant there was supposed to be equal to 6.64 newtons. It was just going to be equal to 6.64 newtons. So my R was going to be equal to what? 6.64 newtons. That is my resultant. Now let's hear the following question. Now they are saying calculate the direction of the resultant force. The direction of the resultant force becomes theta. How do we find theta? Let's go back to that direction, to that diagram that I've just drawn there. How can we be able to determine this theta? How can we be able to determine that theta? So you can see that that theta from that right angle triangle, we can find it from saying what? Tan theta is equal to what? Opposite over adjacent. Because I've got this opposite, I've got this adjacent. That is what I had. So that is what we are just going to use because we are looking for theta there. So I would have just came and said, now theta would be equal to what? To arctan my resultant in my y over my resultant in my x. And what is my resultant in my y? We said in my y it's 3.171 divided by in my x we said it's what? 5.828. And what becomes my direction after doing that? So my direction was just going to be equal to what? 28.53 degrees northeast. So you would have quoted this in a sense to say the resultant force was going to be, or else the net resultant was going to be equal to what? It was going to be equal to 6.64 newtons, 28.53 degrees northeast. Mean to say that this force is acting in the northeast direction. That is how you would have calculated that. Now let's go to question number 3. Question number 3, it is saying define inertia. So inertia is the tendency of an object to resist motion. Tendency of an object to resist change in motion, to resist any change in what? In motion. That is being derived from Newton's law. So it is the tendency of an object to resist the what? Change in motion. It can either stay in its constant state of motion or else at what? At zero or else at rest. Now they're saying a passenger is seated in a fast-moving taxi. When the taxi driver suddenly slams on the brakes, use your knowledge of Newton's laws to explain why the passenger moves forward when the brakes are applied. So this is also given by that inertia or else the Newton's first law. So we would see that why the passenger would continue moving. Maybe let me just get to use this side where I would have just said 3.2. So you would see that, let's say this is your taxi. I would simply try to draw a pictogram of a taxi and its passengers there. Just pardon my drawing there, but I'm sure it will make sense. So let's say this is a taxi, and this is your what? This is your driver. So now this is a passenger. Maybe this passenger is actually what? Seated on the back seat, or else he will be seated next to on the passenger seat. They are saying, why is it that when the driver slams on the brakes, this car would actually come to stop? Why will the passenger continue moving? It is because initially, so we are saying that initially both the taxi and the passengers both the taxi and the passenger we're moving at the same speed. So initially, both the taxi and the passenger were moving at the same speed. Now the driver slams on the brakes, so the taxi comes to rest. When the taxi comes to rest, however, you would see that it is due to the brakes. Due to the what? Due to the brakes. And then we are saying that, however, the braking force only acts on the what? On the taxi, not on the passenger. The braking force only acts on the passenger, not on, it only acts on the taxi, not on the passenger. The braking force only acts on the taxi and not on the passenger. So this is where we would say due to inertia, the passenger will therefore remain moving, will therefore remain in motion. So inertia is the property or else the tendency of an object to actually resist any change in that motion. So we are saying that as they were both moving, the taxi and the what? And the passenger, the driver slams on the brakes, and these brakes, they only act upon the what? Upon the wheels of the taxi. So the force is acting only on the taxi. It does not act on the what? On the passenger. So the passenger will still continue moving because he has that tendency to resist that what? That change in what? In the state of motion. So this is how you would have explained. You would say that initially both the taxi and the what? Both the taxi as well as these passengers, they will be moving at the same speed. When the brakes are slammed, the frictional force or else the braking force will act on the what? On the taxi alone, not on the passengers. So since there is no net force that can change the state of motion of this passenger, he or she will continue moving. That's the reason why we would need seat belts. That is the reason why we later invented what? Seat belts. So that was going to be the answer for what? For 3.2 there. Now 3.3, explain why wearing a seat belt is a safety measure for the occupants of a vehicle. So wearing a seat belt would actually provide what? Safety, because the seat belt would actually stop you to continue moving when brakes are applied. So you can actually get to say that the seat belt will help to stop you when the brakes are applied. This is due to Newton's third law. Newton's third law, which says that actions and reactions are equal and opposite. So you would see that your seat belt, as you would be seated there, the seat belt itself would act in that direction, whilst when you're acting in that direction. So the force that is being applied by you as you want to continue moving is the same force that would be applied by the seat belt to actually stop you from moving. So the net resulting force would be zero. So that would act as a safety measure. That is due to Newton's third law. So the seat belt helps to stop you when the brakes are what? Are applied. It helps to create a net resultant force of zero. so that you can actually what? Stop moving. Or else it helps to actually balance your force that you would be applying when you are actually what? Moving forward. Now let's go to 3.4. 3.4 is saying a crate of mass 8 kg lies on a rough inclined plane 25 degrees to the horizontal. The crate begins to slip when the angle of inclination exceeds 25 degrees. Refer to the diagram. So if the crate moves only when we start exceeding this. So it simply means that when we are still at this angle, this object is actually what? It would be resting on this inclined plane. It won't get to move, meaning to say that the parallel weight component would be equal to the what? To the opposing force of motion, which is equal to the what? To the frictional force. So this weight parallel component would be balanced by the frictional force as long as the angle is equal to 25 degrees Celsius, 25 degrees or less than. But once we exceed that, that is where we can be able to overcome the maximum what? Static friction. Now let's hear our questions. Define the term static friction. Static friction, this I can come and say this is the opposing force of motion on a what? On a stationary object. This is the opposing force of motion acting on a stationary object. It acts on a stationary object. So if that is the case, now they are saying draw a free body diagram showing all the forces acting on the crate. So you want the forces that are acting on this crate. So you would see that due to the weight of this object, we are going to have what? We are going to have a vertical component, or else we are just going to have a vertical force that is the weight of that object. And then this weight would be in parallel component as well as in what? In perpendicular component. We can be able to resolve it. Some of it is acting towards this parallel component on the plane. Some of it is acting what? On the perpendicular plane. So what balances what is on the perpendicular plane becomes what we refer to as the what? As the normal force. So that we do not have some spinning of this object. And then we are also told that this incline is actually what? Rough. So we are going to have what? Frictional force. So here I can actually get to come and draw a dot to represent my object, and then draw the weight component, and then draw the normal force. And then after drawing the normal force, I would also have the what? The frictional force. Like that. That would be the what? That would be the free body diagram. So the number of marks gives you a hint of how many forces you are supposed to what? To represent on your free body diagram. Now they are saying, after we have said that, now they are saying, define the term normal force. Define the term normal force. What is a normal force? A normal force is a force that is due to the what? To the plane, or else maybe that is due to the what? To the surface. That acts perpendicular to the what? To the plane of the object. So this we can actually get to say that this is a force So this is the force that is exerted by the surface on the object that acts perpendicular. So here I said this is a force that acts perpendicular to the plane of the surface on the object due to the surface. So it is exerted by the surface on the object. So let's say we have got our object that is lying on a horizontal plane like that. That force that is acting due to this surface. So this surface is the one that is actually what? Applying or exerting this force. And this force, you can see that it is perpendicular to the what? It is perpendicular to the plane of the surface. That is what we call a normal force. So that is how you define a normal force. Now they are saying calculate the magnitude of the maximum static frictional force acting on the crate. So from what was said, I was explaining here to say that as long as here they said a crate of mass 8 kg lies on a rough horizontal plane at 25 degrees to the horizontal. And then they're saying the crate begins to slip when the angle exceeds 25. When the angle theta is greater than 25, that's when we have what? We have motion. Before that, there is no motion. Mean to say that when the angle is less or equal to 25 degrees, the object is at what? Is at rest. Therefore, it simply means that whatsoever component of the weight is in that direction will be balanced to the what? To the frictional, static frictional force when we are at what? At the angle of what? Of 25. So this is the parallel what? Weight component of the force. So at some point in time, allow me to say that at theta is equal to 25 degrees, we have our static frictional force being equal to what? To our parallel weight component, which is given by what? By mg sine theta. So our static frictional force can be given by the mass, which is 8 times the gravitational acceleration, 9.8, and then times what? 9 times sine 25. And that gives you what? Your static frictional force. That is how you would have calculated that static frictional force. That is how you would have just what? Calculated that static frictional force. So here where they said calculate the magnitude of the maximum static frictional force, that would be Fs is equals to mg sine theta, which is 8 times 9.8 sine 25. And that is supposed to be equal to 331,33 newtons. So I see that here on top, I skipped this question. I'm sure it was due to the information that I had wrote on top of it. Right. This question was saying, calculate the magnitude of the normal force. We know that the normal force here is being balanced by the what? By the gravitational perpendicular what? Force. The normal force is being balanced by the gravitational perpendicular force. So just allow me to. So we are saying that here the weight, our weight, which is given by mg, would actually be resolved into that component, which is Fg parallel, and then also into that component, which is what? Fg perpendicular. And this Fg perpendicular is being balanced, or it is balancing our what? Our normal force due to the what? To the surface of the plane. So you can simply see that Fn would be equal to what? To Fg perpendicular. It will be equal to Fg perpendicular, which is given by what? Mg cos theta. So this was going to be equal to 80 times 9.8 cos of 25. So that was going to be equal to what? That was going to be equal to 710,55 newtons. So that was going to be our normal force there. So that is how you calculate your normal force. And we say that our maximum static frictional force, here would be equal to what? It would be equal to the what? To the parallel weight component. Why? Because as long as we are still within this angle, the object is not moving. So these two forces are equal, these two forces are equal. So this would be equal to what? Mg sine theta. That's why we said 80 times 9.8 times sine 25. That is how we found that. Now, let's look at the following questions. So for our normal force there, we're just going to have what? Mg cos theta, which was going to be 80 times 9.8 cos 25, giving you 710,55 newtons. Now they're saying calculate the coefficient of static friction between the crate and the plane. So we know that our static friction can be given by what? By the coefficient of static friction times the normal force. This is an equation that we know. So if that is the case, how can we find this coefficient if we now know the normal force and the static frictional force? So the only logical or else the easiest way there is to make mu as the subject. So let's say 3.46. It will be to say the static coefficient of frictional force would be equal to that divided by that. So I have this being equal to what? 331,33 newtons divided by that being equal to 710,55 newtons. If that is the case, if I divide those two, I'm supposed to get 0,466. So my answer there can actually say mu, which is the coefficient of what? Of frictional force, the coefficient of frictional force there. I can come here and write it to say it is equal to what? The coefficient of it will be equal to 0.47. That is how you calculate it. Now they're saying if the mass of the crate is increased, will the crate begin to slide? Yes or no? So what is it that can make our what? Our crate to slide? We are saying that for our crate to slide, we now so they're saying if the mass of the crate is increased, will our crate begin to what? To slide? Choose from yes or no. So if the mass of the crate is increased, we can say that our FG parallel is going to what? To increase. If FG parallel is going to increase, then we can be able to actually get to have FG parallel being greater than the what? The static maximum what? Frictional force. So you would have just came here. Let's try to answer this from this perspective of what we're doing here. I'll take it to that side. So I have got an object that is inclined there. And as it is inclined, the mass is the one that is being changed. And I have got a weight parallel component, which is FG parallel. And I have got my maximum static frictional force, which I now know to be equal to what? To be equal to 331 point what? 331,33 newtons. Now, if this is given by mg sine theta and m increases, that is to say, let's say it now becomes 81. It will now be 81 times 9.8 sine 25. That would be Fg parallel. Is going to be equal to what? Let's get to use that. It would be 81 times 9.8 times sine 25. That is going to give you 335.474 newtons. And you can see that now the new Fg parallel is greater than the what? The static maximum frictional force. Since this is now greater than this, then the object will simply move. So that is the reasoning that is there. So they are saying, give your answer as yes or no and explain why. So the explanation that you can simply give there is to say that, let me just get to move up a bit. I have explained how. So now I would come and say 3.47. You are just going to say yes. And then you would say that the component of the gravitational force parallel to the plane of the surface will increase with increase in mass of the object. If it will increase, that is to say Fg parallel is equals to mg sine theta. That is what we have seen there. Therefore, Fg parallel will be greater, Fg parallel nu will be greater than what? Our static maximum kinetic friction. Maximum static, this gravitational, the component of the gravitational force parallel to the what? To the plane would now be greater than the what? The static frictional force. Therefore, there will be what? There will be a net force. There will be a net force because here the net force, before the net force was equal to Z. That's why they were balanced. That's why there was no movement. So now there will be a what? A net force, which is not, or else which is greater than what? Z. A net force greater than Z. Therefore, there will be what? There will be movement, or else what? Acceleration. That is what you were just supposed to say there. So you're supposed to be explaining your answers in terms of the theorems that you know. For example, Newton's laws, first, second, third. What do they say? You know that. So here, the theorem that worked was going to be Newton's second law. Once we have got a net force, then there will be movement. So you would have said yes. Why? Because now Fg parallel nu will now be greater than what? The static maximum frictional force. Hence, therefore, there will be what? Net force greater than what? Z. So acceleration there will now be greater than Z. That's the reason why there is movement. If the angle of inclination is changed from 25 to 20, how would this change affect the static frictional force acting on the crate? Choose from increase, decrease, or remains the same. Explain the answer. We say that the static frictional force, or else the maximum static frictional force, is equal to what? Mg sine theta. So this is 8 times 9.8 times sine 20. Because initially, due to this, our static frictional force was equal to 331 point what? 33 newtons. Now it will be equal to what? If you say 8, let's say 8 times 9.8 times 9 sine what? 20, it is now sine 20. It is now sine 20. It will now be equal to 268. It will be now be equal to 268. You can see that this is now less than the, so the new is less than the what? The old. So you would see that the static frictional force would actually what? Get to decrease. It would actually get to decrease because the magnitude of this parallel what? the parallel component of the gravitational force has decreased. So it is actually going to what? To decrease. So what is it that you're going to say? Because at some point in time, yes, you could use those calculations. You could actually you calculate your first static frictional force, which is what? Initial, using what? 25 degrees. And then you see that this would be greater than what? The static frictional force 2, which is when you are using what? 20 degrees. And then you can actually get to give conclusion using these calculations. Or else you can say that it will decrease because the gravitational component, the gravitational component parallel the gravitational weight component of the object parallel to the plane or else of the surface. We now get to decrease, and our static frictional force is being given by that. Decreases or else becomes small as the angle decreases. As the angle decreases or else becomes small. That is what we're just supposed to say there. Now let's go to question number 4. Let's go to question number 4. So 4.1 is saying two blocks of masses 1 kg and 3 kgs are connected by a light inextensive string. The blocks are initially at rest on a smooth horizontal surface. A force F of magnitude 9 newtons is applied to the 3 kg blocks as shown in the diagram. So everything that they've said there, it is given in this diagram. Now they're saying state the Newton's second law in words. We know that the Newton's second law can be given by that equation or formula. Now they're saying state it in words. They want it in what? In words. They want it in words. So you would come and say 4.1. You'd come and maybe let's get to say you would say 4.1. The Newton's law states that when a non-zero resultant force or else net force acts on an object, the object will accelerate. The object will accelerate. The object will accelerate so maybe I was just supposed to say yes. I now want to use that space. So pardon me there for me to start all over again. Because others will say, say. So you would say that when an object is acted upon by a net force or else when a net force, let's say when n non-zero resultant force, which can be what? F net, acts on an object. The object will accelerate with an acceleration that is equal, that is directly proportional to the magnitude of the force being applied, of the magnitude of, so when a non-zero resultant force or net force acts on an object, the object will start to accelerate with this acceleration that is directly proportional to the net force that is being applied. So it will be directly proportional to the magnitude of the what? Of the force applied and in the direction of that force. Or else in the same direction with that force, but inversely proportional to the what? To the mass. Inversely proportional to the mass of the object. So the acceleration would be directly proportional to this net force, but it would be inversely proportional to the mass of the object. That is what Newton's second law states. Now they're saying draw a free body diagram showing all the forces acting on the 3 kg block. Draw a free body diagram showing all the forces acting on the 3 kg block. So we now want the free body diagram of the forces acting on the what? On the 3 kg block. So what are the forces that are acting here? We have got weight, and then we have got a normal force, and then after a normal force, we would have this force that is acting in this plane. Maybe we can say F, and then we would have what? Tension. So how many forces are there? 1, 2, 3, 4. And that is the number of marks that are given there. And they told us that this is a smooth surface, so there is no friction there. So you were just going to draw a diagram like this, to change colors there, to say that you have got a weight component, which is mg. So that mg is represented by what? You can either use W, you can use Fg. And then you have got a normal, force, which can be represented by Fn. Others, they use what? Others, they use N to represent that normal force. And then you would be having what? You are having a force that is at an incline, which is just F applied, which is this F applied. And then you are also later having a what? You're also having tension due to the other block. Tension due to the other block, like that. That is how you would have just what? Drawn that diagram. Others, they use FA to represent force applied. It is still the same as long as you are consistent with the use of this. So we have got 4 marks and we need to represent what? 4 forces. If that is the case, now let's go to, by applying Newton's second law to each block separately, calculate the magnitude of the acceleration of the blocks and the tension in the string. Now, maybe I'll need these. So what I can do is to take these this side so that at least I can have them where I can see them whilst I'm working out everything that I need to work out there. Yes. So that when I'm referring to whatsoever that I'm referring, you can see. So let's take, for example, forces on the 1 kg block. So forces on the 1 kg block, we are going to use Newton's second law. F net is equal to what? To mass times acceleration. Now, what are the forces that makes F net here? There is no force acting this side. There is only tension. So we can actually say tension is equal to what? To mass times acceleration. That is 1 times A. That is simply equal to what? To acceleration there. 1 times A. Now, if that is the case, let's go to what? To forces acting on the 3 kg block. So the forces that are acting on the 3 kg block would have our Newton's second law giving us what? Mass times acceleration there. Now, F net, what are the forces that are acting here on the horizontal plane? We have got this force. So would have its what? Vertical component, and would have its what? Horizontal component. So its vertical component would be what? Would be F cos theta there. So we have got F cos theta, and then we have got this tension T. So we can actually have what? F cos theta there becomes what? 9 cos 25. That is in that direction. So let's take going to the right to be positive so that this one becomes negative. Minus T is equal to mass there is 3 times the acceleration. Now we now know from equation 1, we now know our what? Our tension. This tension here, these two, they are the same. So the tension that is acting here, the tension that we are saying tension, is the same for both 1 kg and 3 kg. So we can simply now substitute the value for tension that we found, which is just acceleration. So I can come and say what? 9 cos theta becomes what? 9 cos 25. That becomes 8.157. So I can say 8.157 minus acceleration is equal to what? 3 acceleration. That becomes the new equation 2. Now I would transpose this that other side. I would transpose that other side. It becomes 8.157. 8.157 being equal to what? To 4a. Because if I transpose the negative, it will become a positive. So they will add. Now to find acceleration, I'll divide by 4. Divide by 4. And that is going to give me what? The answer that I was going to get there was going to be equal to 2. So the acceleration there was just supposed to be equal to 2.04. So my acceleration was going to be equal to 2.04. So this was going to be 2.04 meters per second, which is my acceleration. But that is not what I'm looking for. I'm looking for tension. From equation 1, if we can remember, we said tension is equal to 1 times the acceleration. Therefore, this would be equal to what? 2.04 newtons, because we are saying 1 kg times 2.04 meters per second per square second. So this would be equal to what? 2.04 newtons. That is how you calculate the magnitude of the what? Of the acceleration and the tension in the string. So the magnitude of the acceleration was just going to be what? 2.04 meters per square second. Then the tension, it was going to be equal to 2.04 newtons, like that. So that is how you would have done it, by applying Newton's second law on all blocks. Now let's get to see what 4.4 is saying. 4.4 is now saying the 1 kg block is replaced by a block with a bigger mass, while the force applied on the 3 kg block remains unchanged. Set whether the tension calculated in 4.32 will increase, decrease, or stay the same. We say that tension is equal to mass of that 1 kg block times the acceleration. The acceleration remains the same. So now what is changing is the mass. So if the mass becomes big, let's say we now have got 2 kgs, it will be 2 times A. So it will be 2 times 2.04. So definitely it's going to be what? 4.204. It is going to be what? It is going to be big. It is going to increase. So since our tension here is dependent on the mass of the what? Of the first block, as the first block's mass increases, our tension will also get to increase. So what is it that you are going to say there? You are going to say increase. It was going to increase. Why was it going to increase? Why was it going to increase? We are saying that if the mass of the 1 kg block increases, comma, it will require a bigger force to pull it, comma, therefore tension will increase. The tension will increase. That is what we are saying. For you to pull a 1 kg block, it's easier than to pull a what? A 4 kg block. It is easier than to pull a what? A 4 kg block. So the tension will increase as the mass is what? Is increasing. Because this block is the one that is just being pulled. It is just being pulled. We already have our force being applied that other side. So that is the one that is being pulled. Now let's go to question number 5. It says, state Newton's law of universal gravitation in words. What is the Newton's law of universal gravitation in words? So I would say that Newton's law of universal gravitation in words we know that that law is given by F is equals to what? G mass of A times mass of B all over the radius squared. So we are just saying that every object on Earth, or else every object on the universe, because if I say on Earth, it will appear as if this gravitational force of attraction applies to what? To Earth only. Every object on the universe, applies a force of attraction towards every other object. So us in each and every object that exists in the universe, we are always attracting each other with a force of attraction that is directly proportional to the product of the masses of the object, and inversely proportional to the distance between them. Or between their centers. Simple like that. That is what Newton's universal gravitation law states. So that was going to be equal to 5.1. Now let's hear what the other question is saying. Differentiate between mass and weight. So mass is the total amount of matter, whilst weight is the attraction of this total amount of matter towards the center of the earth. So this is a force, this is the total amount of matter. This becomes a vector and this becomes a scalar quantity. So you would have said there, at some point in time, someone who is clever would come and draw a what? Maybe a table. And then you would say mass, and then you would say weight. And then you would say that total amount of matter in an object. And then this becomes the what? Force of attraction due to gravity. And then this one is what? It's a vector. And this one is what? It's a scalar. That is one way you can differentiate those. And you get your 2 full marks by defining this and defining that, stating that this one is a vector and that one is a scalar quantity. By having that, you would have fully what? Differentiated between mass and weight. Now they're saying a 70 kg mountain climber reaches the top of Mount Everest, 8.85 kilometers above sea level. Take the surface of the earth to be sea level. Take the surface of the earth to be sea level. Now they're saying at the top of the Mount Everest, determine the acceleration due to gravity. We know that the acceleration due to gravity, like we have done, it is given by G is equals to big G times the mass of the what? Times the mass of this object divided by r squared. Now they're saying take the surface of the earth to be the sea level. So if he is 8.85 kilometers above sea level, he is 8.85 kilometers away from the center of the earth. So you would come here, you use G. We know that G is 6.67 times 10, which is times 10 to the power negative 11. And then times the mass that is given, it's 70 kgs, divided by the square of the distance, which is what? This is supposed to be in meters. So if it is supposed to be in meters, we now need to what? So we are saying that this becomes the what? The distance or else the radius of the earth, the distance from the center of the earth. This being the surface of the earth, they say take the surface of the earth to be sea level. So from the surface of the earth, this is the surface of the earth. And this is where this climber is. Maybe the climber is here, 8.85 times 10 to the power 3 meters. That is the distance. What about from the center of the earth? That is the other thing that I had overlooked. So this becomes the radius. So you would add this distance plus that distance to become the distance in between these two people. The mountain climber and the earth. The distance in between them becomes the radius of the earth and this distance from the surface of the earth. So that would simply become what? I would come here and then I would need to what? To add the radius of the earth. We know that the radius of the earth is just 6 point what? It's 6.6 6.6 what? So the radius of the earth at some point in time, we can get it from what? From our information table. So this is our information table and the radius of the earth is given by this one. So the radius of the earth there is 6.38 times 10 to the power 6. So this is the value that we want. After taking that value, we are going to add it to the what? To the distance away from the what? From the surface of the earth. So here we are going to say what? 6.38 times 10 to the power 6 plus 8.85 times 10 to the power 3. We need to square this. After that, we then get to find the what? The gravitational acceleration there. So the gravitational acceleration there, if we use our calculators, we are supposed to find something like 9.77 meters per square second after rounding off. So we are just punching in these values and then we would find this answer. So this is the formulation that you use for calculating your gravitational acceleration. And this should be the mass of the object. This should be the distance from the center of the earth to where the object is. So the center of the earth, the radius of the earth is given like that. So if an object is said to be on the surface of the earth, you just use that. But if they tell you that he is above sea level, it simply means that they said sea level is the surface of the earth. So the distance from here to the surface of the earth is actually added to the radius of the earth. That is what we have done here. So at some point in time, I would actually get to say, now let's do what? They're now saying calculate the climber's weight. Now you now know the gravitational acceleration. You can just calculate the climber's weight by saying W is equal to what? Mg, which is given by the mass 70 kgs times the gravitational acceleration 9.77. You can use 9.77. So this becomes 9.77. And that gives you what? Your weight in newtons. That should actually be equal to 683.90 newtons. That is how you calculate that weight. Now, after we have said that, the question is now saying, a learner makes the statement, an astronaut orbiting the Earth experiences weightlessness because he or she, let me just wrap this. Let me just wrap this. We now know that there you are just supposed to apply weight is equals to mg. And then here you're supposed to say g is equals to gm, mass of the object, divided by the distance from the center of the Earth. And then now they're saying an astronaut orbiting Earth experiences weightlessness because he or she is beyond the pull of Earth's gravity. Define weightlessness. What can be defined as weightlessness? This is the tendency of you not feeling any force of attraction towards you. So that is the sensation experienced when all contact forces are removed. That sensation that you are not feeling any force of attraction. So you would say this is the sensation experienced by a body. This is the sensation that is experienced by a body. So let me say this is the sensation experienced by this is the sensation experienced by a body when all forces are removed. When all forces are removed. Just like a feather, we remove all the forces that are acting on it. It becomes weightlessness. So this is the reason why we would call that the fall of a feather is what? Becomes free fall. It is just falling without any without any force that is acting upon it, because at some point in time of it not having what? Weight, being light. So that can be weightlessness. So that is how we can define weightlessness. That sensation that is felt by a body due to the fact that we have removed all the forces. There are no any force of attraction, any force of pull, of push that is acting upon it. Now, is the statement correct? Choose from yes or no. That an astronaut orbiting the Earth experiences weightlessness because he or she is beyond the pull of gravity. There is still the pull of gravity there. That's the reason why the astronaut would appear as if he's floating. But the main reason is the speed at which he or she is moving is the same as the speed of what? Is the same as the speed of every object that is moving what? Around the what? The Earth. Or else his speed as he is moving towards the Earth is actually overcome by the speed of him, which is horizontal, that is orbiting around. So the speed that would act upon him horizontally would be greater than the speed towards, because the force of attraction is actually what? Is actually lower. That is what we are saying. So this is actually force. There is still the Earth's gravity, which is pulling this astronaut. But it's simply because now the force that can actually be acting on that astronaut will be only the what? The gravitational force. There is no any other force. Hence, therefore, if it is only gravitational force, it can actually what? Make him fall on a what? On a free fall. So you would say no, because the astronaut now the astronaut still experiences the gravitational force. However, it is the only force of it is the only force acting upon him. Only force acting upon him. Imagine yourself when you are in a lift. You would see that when the lift is moving down, if we are to put a scale here, you would appear as if your scale, your weight is equal to zero. Why? Because you are going down at the same speed as the lift is going down. So you won't be able to exert, you won't be able to actually get to feel or else have a sensational force due to the normal which can be actually be applied by this scale. So the only force that would be acting would be gravitational force that would be acting on the same weight, on the same scale, same lift, as well as on you. So that is what we refer to as weightlessness. So that is what is happening on the astronauts. They are experiencing gravitational pull only. There is no reactional force whatsoever. That's why we won't be able to actually get to determine their weight. So we can say their weight is equal to zero because there is no reactional force that will give us this weight. So we can actually simply say that they are in free fall. They are in free fall. They are in free fall. That's the reason why we would say they are weightlessness. Now let's go to question number 6. Question number 6 is now saying state the Coulomb's law in words. State the Coulomb's law in words. The Coulomb's law, we know that it can be given by what? By F is equals to K Q1 over Q2 all over what? R squared. Now they are now saying state that law in words. So what you would have just came here and said, you would have said that the magnitude of the electrostatic force acting on a point charge due to another point charge can be directly proportional to what? Is directly proportional to the product of these 2 point charges. Directly proportional to the magnitude is directly or else is proportional to the product of the magnitude of the point charges, but being inversely what? But being inversely proportional to the distance in between them. So I say that my space here will not allow me to actually get to what? To state that law fully. So I'm just thinking that it is easier for us maybe to have our space where we can just get to start answering our questions like here. So this is just the law that I'm describing, which is here. So it is to say that according to that law that I just wrote its equation there, you can be able to describe that. So we are saying that the magnitude of the electrostatic force, which is this electrostatic force that is being exerted by a point charge on another point charge, is directly proportional to the product of the 2 point charges and inversely proportional to the distance between them, and inversely proportional to the what? To the distance in between them. So that is what Coulomb's law states in words. So here you are given this information that is here on the diagram. That is what was being described there. Now they're saying calculate the electrostatic force that sphere A exerts on sphere B. Electrostatic force. Now we say that F is given by what? K, Q1, Q2 all over R squared. So now our K, we know that our K is always what? 9 times 10 to the power of what? 9. 9 times 10 to the power of 9. And then Q1 is what? 4 micro. So it will be 4 times 10 to the power minus 6. I'm sure we know that micro means 10 to the power negative what? 6. And then the other one is also 4 micro. So we take the magnitude, we do not take the sign. And say 4 times 10 to the power minus 6. And then all over, we divide by the distance in between them squared. We divide by the distance in between them squared. Now the distance is 0.40 squared. What would become the what? What would become the electrostatic force that sphere A exerts on B? What becomes that force? So you would see that that force would become what? 0.9 newtons. That is what we are supposed to find there using the information that is given in this equation. Now they are saying draw the electric field pattern due to the two spheres, due to these two spheres. So we know that the electric field, it moves from the positive to the negative. So we can have our negative here. I was just trying to draw a circle. And then our negative is always what? Receiving. Like that. So maybe I would have just said what? Because we are saying it is moving from the positive to the negative. So this being the positive, so pardon me on my drawing there, but I'm sure you can see what's more important is the idea of what is happening there, because they said draw the electric field that would be due to that. So that would have been so that you would have these ones attracting like that. At some point in time, you would have the positive running to the what? To the negative. You would have the positive running to the negative. So if you were someone who was using this is a sketch. So if you are in the exam, you would have just drawn a neater diagram than mine. But that is what you were just supposed to draw there. Now, if that is the case, now they are saying sphere B is now replaced by a third sphere C, as it is shown there, carrying a charge of negative 9 microcoulombs. P, this one is a point charge along that is joining the centers of the spheres as shown in the diagram. Now they're saying define electric field at a point. This is just given by force per unit point charge. So the electric field point is the electrostatic force acting per unit point charge. So you would say that is the electrostatic force per unit point charge, or else acting per unit point charge, which is given by E is equal to F per unit point charge, like that. Now, if the net electric field at point P is 0, calculate the distance between point P and the center of sphere A. Distance between point P and the center of sphere what? A. So what I'm going to do there, let me just get to move it up a bit. Just like that. I'm going to call this distance x, and this distance 0.4 minus x. This distance to P there, this distance there. So that the distance that we are looking for is what? It's x. Now, we know that the net electric field would be equal to electric field on P due to A plus electric field on P due to C. Now, you would see that this is a negative, this is a negative. So this one being a positive, it will be attracted that side, attracted that side. So these two, they are going to give a repelling what? A repelling net force. Mean to say this is going to act in that direction, that direction. So we can choose this to be positive, so that we can see electric field due to what? Due to C on P minus electric field due to A on P is the one that they're saying is equal to what? To 0, like that. So if that is the case, I now need to find the electric field on P due to C. So on P due to C, it is what? F over Q, that is just Q, K of what? Of C all over the distance between C and P squared. That is to say, K, we said it's 9 times 10 to the power 9 times the charge there is just what? 9 times 10 to the power negative 6 divided by the distance here. This is the one that we are saying 0.4 minus x bracket squared. What about the electric field due to what? Due to A on P. Electric field due to A on P. That is E A on P. That would be equal to 9 times 10 to the power 9 times 9 times 10. Now we are now having 4 there. It's no longer 9. 4 coulombs. 4 times 10 power minus 6. I just took, this is the charge that I put there. All over, the distance is now at x. So this would be x squared. If that is the case, now I will now come back to this formulation of ours here. And then I will input those values to say that now I now have got 0 being equal to this, which is 9 times 10 power 9, 9 times 10 power negative 6. Divided by 0.4 minus x squared minus the one for A. We said this is the one for A. So the one for A, we have got that, which is 9 times 10 power 9 times 4 times 10 power negative 6 over x squared. That is the one that we are using here. If that is the case, I would come and say minus 9 times 10 power 9 times 4. Here we have got 4 times 10 to the power minus 6, all divided by. So this was E C of P, so that we cannot confuse it. Divided by x squared. If that is the case, I will transpose one of these so that at least we will end up having something of this nature. We would end up having, I will transpose this, 9 times 10 to the power 9 bracket 4 times 10 power minus 6 all over x squared, which would be equal to 9 times 10 to the power 9, 9 times 10 to the power minus 6 all over 0.4 minus x squared. So now if I am to find the common denominator, I will end up having what? 0.4 minus x squared, and then I would have 9 times 10 power 9 times what? 4 times 10 power minus 6 equal to x squared times 9 times 10 power 9 bracket 9 times 10 power minus 6. Given that, I will now come and multiply throughout these brackets to say this is one bracket. I multiply with that bracket so that I will make x the subject there. So by doing that, if we go on and actually make x the subject there, you would end up having your x, being equal to. So the final value that you're supposed to find for your x after making that subject, the final value that I found after making that the subject, I found my x being equal to what? My x being equal to 0.16 meters. So that is the distance between what? That is the distance between A and the point charge. That is the distance between A and the point charge, which is 0.16 meters. So now let's go to question number what? Question number 7. So on question number 7, this is the diagram that you are given. After being given that diagram, they now told you that both switches S1 and S2 are initially closed. They're initially closed. The reading on voltmeter V2, this one, is 18 volts, and the power dissipated by resistor R is 12 watts. That is what they've told you there. If that is the case, they are now saying, calculate the resistance of R, of resistor R, the resistance of resistor R. Given that all switches are closed and this is the power, we know that power is given by what? V squared over R. Now power is given as 12 watts, and then our voltage there is given as what? Our voltage, they're saying it's 18 volts because it's in the parallel circuit. So it's 18 divided by R, and we want to find R. R will just be equal to what? 18 over 12. So what is 18 over 12? Our resistance there was just going to be equal to what? It was going to be equal to, so this is 18 squared. 18 squared. Pardon me, there 18 squared. So if I punch 18 squared all over 12, it was going to give me a value of what? 27 ohms. This was going to be equal to 27 ohms. So the resistance there was equal to what? 27 ohms. Now they are saying, calculate the reading on the ammeter. The reading on the ammeter. If I now know the resistance here and the voltage here, the resistance here and the voltage here, I can calculate the current there. I can calculate the current on this 12 ohm, calculate the current on this 27 ohm, and then I'll add them. That becomes the total current that is running through the here. That becomes the total current here. So for me to find, let's get to say current on the 12 ohm, because I'm saying they're connected on the same parallel connection with the same voltage, I would say current is equal to what? Voltage over resistance. Voltage there is 18 divided by resistance, which is 12. We say that this, if you say 18 divided by 12, you are going to find 1.5 amps. That is current in the what? 12 ohm. Current in the 27 ohm would be equal to 18 over 27. That will give you 0.67 amps. If you add these, it will give you what? Current total, because we are saying current in a parallel circuit, they sum to give you the what? The total current there. So that is actually going to be 1.5 plus 0.67. So this total current was going to be equal to what? 2 point what? If we are to add, we have to find 2.17 amps. So that is the current that is running through this ammeter. If that is the case, now they're saying calculate the potential difference across the 10 ohm resistor. So you would see that across the 10 ohm resistor here, we need to find the potential difference. The potential difference here can actually be given by IR. If I know the total current here and then this, I would find that. So here I was just going to say what? Potential difference there, it was going to be equal to 2.17 amps times 10. That was going to give you 21.7 volts. That is how we were going to calculate that. Now they're now saying when switch S1 is opened, the reading on voltmeter V1 changes to 41.9 volts. Calculate the internal resistance of the battery. The internal resistance of the battery. So allow me to just get to what? To rub through this. So now I now know the voltage there, and I now know the total voltage here. And after that, I would know the total current. If that is the case, I would say that the voltage that is passing through here, it's what? 21.7 volts. The voltage that is passing through this parallel circuit, it's what? It's 18 volts. And they're telling us that the voltage that is passing through, they're saying if this switch is opened, the total voltage that is in here, that is within V1, it is what? 41.9. I'm sure that is it 41.9 or 41.7. Let's check. 41.9. So now we want the internal resistance of the what? Of the circuit. So you would know that the total EMF can actually be given by what? By the total current times resistance in the external circuit plus internal resistance. Or else it can be given by what? By the total resistance in the external circuit plus, the total voltage in the external circuit plus the total volts lost. So we can start by calculating the V lost and then later calculate that, because this is I times R plus this is I times R. So I can find this because I already know this if I know that. So what I'm going to do here is to say, let me feed in the values there. So here I've got 41.9 being equal to this one. We calculated it to say we have got here. I'll take different colors to say 21.7 plus 18, and then I would have my what? My V lost. So my V lost there was just going to be equal to this minus that. That was going to be 41.9 minus 21.7 minus 18. That was going to be equal to what? That was going to be equal to 2.20 volts. Now, I know that this is also equal to IR. Now I know the total current, which is 2.17. That is the total current that is flowing within my what? Within my circuit. That is actually what? 2.17. That is the total current. And then the internal resistance. So to find that internal resistance, I'll just get to divide there, divided by 2.17 volts. So this would be generally equal to 1.01 ohm. That is the internal resistance there. If that is the case, now they're saying switch S2 is now opened while switch S1 is closed. While the reading on the ammeter increases, will the reading on the ammeter increase, decrease, or remain the same? So let's go back to our switches. We are saying that now they are saying we now get to open this one. So this is now totally out. We are no longer having this. And then this is closed. So our current moves here. So you would see that here we said this is 27 what? Ohm. So you would see that the total resistance in the parallel circuit now increases to 27 from what? It increases to 27. So initial total resistance there was going to be what? R12 times R27 divided by R12 plus R27. That was going to give you, if I say product over sum, 27 times 12 divided by 27 plus 12. So initially we calculated to say that this was having a resistance of something like 8.3 ohms. Now the parallel circuit is now having a resistance of what? 27 ohm. So you can see that the resistance has increased. So if our resistance in the external circuit increases from this law that we have given here, where we are now saying that the total EMF is close to that, we are saying EMF is equal to I times R external plus R internal. Where R internal remains the same, this increases, this will decrease because EMF is remaining the same. So here you're just supposed to say that the total current in the ammeter will decrease because the resistance has increased. It will decrease. So what is decreasing is current. Current is decreasing because the total external, or else the total resistance in the external circuit, total external resistance will increase while the total EMF and internal resistance, and internal resistance remains the same. These, they are remaining what? These two, they are remaining the same. Remains the same. Why would these two remain the same? So if resistance in the external circuit, which is R external, increases, the total current there would decrease. That is what we are saying there. Now, question number 7 continues. They are saying a learner sets up the circuit shown below to investigate Ohm's law for each of the two resistors, which is resistor X and Y. Ignore the internal resistance of the battery. Let's hear what they are saying next. The following graphs were obtained from the results of the investigation. This guy is investigating the what? The Ohm's law. Now they're saying state the Ohm's law in words. What does the Ohm's law say in words? It says that the total current that is flowing would say total current flowing in a conductor is directly proportional to the potential difference across the same conductor, given that the temperature remains the same across the same conductor, given that the temperature remains constant or else remains the same. So when temperature is constant, the current that is running through the conductor is directly proportional to the what? To the potential difference across the same conductor. Now they're saying use the graph to determine the resistance of Y. How do we calculate the resistance? We want resistance of Y. Resistance can actually be given by what? R is equal to what? V over I. So we can see that it becomes the gradient. So I'll take this point there, and then I'll try to what? Calculate my gradient. So I'm having 0.9 there and 12. So it is more like this is going to be equal to what? 12 minus 0 over 0.9 minus 0. That gives me what? That should actually give me 13.33 ohms. That is the resistance of what? Of Y. Now let's hear what the following question says. Now they're saying resistor X and Y are connected in series to a battery circuit. Which resistor X or Y would be more suitable to boil the same mass of water at a faster rate in an electric kettle? So we know that what is being determined, the power. So we know that power can be given by V squared over what? Over R. If they are connected in series, they are having the same current, these ones. So the one that is actually, because this can be V squared or else I squared R, the one that is going to have what? The greatest resistance is the one that is going to dissipate what? More energy. So that is the one that is more suitable. So here we can just get to look at the slope. So the slope of Y is greater than the slope of X. So Dave just came here and said resistance of Y would be greater than what? Resistance of X. Therefore, power of Y would be greater than what? Power of X. Because I'm saying that they say that these resistors are connected in series. They are connected in series. When they are connected in series, the current that passes through is the same. So what determines there becomes the resistance. So the power dissipated by Y would be greater than. So Y would be highly suitable. So you are saying Y, and then what is the answer? You would say that the current remains the same. Therefore, the higher the resistance, the greater the power dissipated, the greater the power or else energy dissipated. Energy dissipated. And that is what we are looking for. And you'd actually get to see that resistance of Y is greater than what? Resistance of X. Because slope of Y is greater than what? Slope of X. Simple. That is what we are just supposed to say there. Now let's go to our last and final question, which becomes our last lap. Question number 8. In the diagram below, the north pole of a bar magnet is being pushed into a coil. The EMF induced in the coil is recorded by a galvanometer, which is this galvanometer. Now they are saying, when the bar magnet moves in and out of the coil and the bar magnet exert a force on each other. Is this force mechanical, electrostatic, or magnetic? This is magnetic. This is magnetic because we are using the what? The electromagnetic induction. It is magnetic. it is due to this magnetic field. And then state the direction of the induced current through the galvanometer. Choose A to B. So what we do is we use the what? The right hand rule. We use the right hand rule. It is actually called the solenoid right hand rule. So the solenoid right hand rule says that we actually get to kill our we actually get to point our big finger towards where the north is actually pointing. So this is where our thumb will be pointing on our right hand. So we are using what? Right hand. Our thumb is pointing in that direction. As our thumb is pointing in that direction, some they would ask why. Okay, fine. Let me explain. From the what? Let me so we are simply saying that, just a moment. I don't know what's happening here. Yes. We are saying that according to according to Faraday's law, he said that whenever there is a change in magnetic flux, there is what? There is an EMF that is induced, and that EMF that is induced is directly proportional to the rate of change of EMF. But Lenz now came to say that the EMF that is induced is in the opposite direction to whatsoever that is inducing it. So if we have got this this magnet actually being directed in this direction, having a north pole here, it means that on our far left we are going to have a north pole so as to repel this to go outside. Once we have this north pole repelling this to go that side, it simply means that the force that is going to be induced here, which is that of the magnetic force, it will be in that direction. So we usually say that if you are using your what? Your right hand rule. If you are using your right hand rule on a solenoid, you have to point your finger, which is your thumb, towards where the north is actually pointing within this magnet, as the magnet is entering the what? The solenoid. If you are having a south pole here, it means that your thumb would be pointing towards that side. But if you're having a north pole here, your thumb will be pointing that side. And then your fingers, they will curl. Now they would simply curl in the direction. You know that your fingers simply curl in that direction. They will start rotation in that direction. So it simply means that this is the direction of our current. So our current is actually moving in that direction, entering like that, and then it will leave like that. So they want the direction of our current as we are moving past the galvanometer. So it will be from A to B. So these are the what? These are the middle fingers. So the middle fingers will give us what? Current. Whilst the thumb is going to point towards the what? The north. Towards the north there. So our current was going to be from what? From A to B. That is how you would have determined that. Now they are saying write down the reading on the galvanometer when the bar magnet is at rest inside the coil. When it is at rest, the reading is 0 because there is no change in magnetic flux there. A coil is made up of 100 turns of insulated copper, each having a circular area of that. The coil is placed in a uniform magnetic field, which is having that in such a way that the angle between the magnetic field and the normal to the circular plane is that the coil is then rotated so that the angle changes from 70 in 0.2 seconds. It changes to 70. So we are changing the what? The angle there. So now they're saying state the Faraday's law of electromagnetic induction in words. So the law is given by what? By this equation. So you are just defining that equation in words, where you are saying that an EMF is induced in a conductor when there is change in magnetic flux within that same conductor, within that same conductor. Now, the induced EMF will be directly proportional to the rate of change of the magnetic flux. That is what the Faraday's law says. It says that an EMF is induced whenever there is a change in magnetic flux within a conductor. And we are saying that the induced EMF will be directly proportional to the rate of change of that what? Magnetic flux. Now they're saying calculate the magnitude of the EMF induced in the coil. So the EMF induced in the coil there, we now need to see the given data. So here I have got what? I have got N being equal to 100, and then I have got what? The area being equal to 4.8 times 10 to the power negative 4. And then I've got my magnetic field B being 3.9 times 10 to the power negative 4 Tesla. This one being square meters. And then now the angle is the one that is changing from 30 to 70 in 0.2 seconds. So allow me to just get to take that information there to say what we want to do is our induced EMF, we can only calculate with that equation. So now the number of turns, they're equal to what? To 100. And then the change in magnetic flux now, we can say the change in magnetic flux, everything has to be divided by what? By the time taken, which is just 0.2. It is phi is equal to B a cos theta. So I would say 3.9, which is the given what? Magnetic what? The given magnetic field. So it will be 3.9 times 10 power negative 4 times the area. The area is given as 4.8 times 10 to the power of what? Minus 4 as well. And then it will be cos theta. So now you would have cos what? Cos theta final minus theta initial. That is what you are going to have as the what? As the change in magnetic flux. You are going to have theta final minus theta initial. So here, what I was just supposed to do here, let me just say I would have the initial phi and the final phi. So phi initial would be cos 30. Phi final would be due to cos 90, cos 70. So these two is phi final, phi minus. So here I would have phi final minus phi initial. So I need to have these two values. So what becomes this value? What becomes that value? That is what I just need to calculate there. So 3.9 times 10 to the power negative 4. And then times, I have got 4.8 times 10 to the power negative 4 as well. And then now times, I have cos what? Cos 30. So that value was just going to be 1.62 times 10 to the power minus 7. What about this other one? What about that value? So this one would be, let me say 5.5 times 10 to the power minus 8. If that is the case, I'm just going to substitute these values in that equation. So EMF was going to be equal to negative 100 times 5.5 times 10 to the power minus 8 minus 1.62 times 10 to the power minus 7. And then all this divided by 0.2. So my value that I was supposed to find there for my EMF was just supposed to be equal to 4.9 times 10 to the power negative 5 volts. So that is how you calculate your what? Your EMF. That is how you calculate your EMF. So 8.42. That is how you calculate your EMF. Now let's hear the last and final question. Let's hear the last and final question. You can allow me to rub them. Just a moment. I don't know what's happening here, guys. Yes, at least. So our so the question is actually saying calculate the current induced in the coil if it is an effective resistance of what? Of 2. We know that current can be given by what? V over R. So the voltage that we calculated, we said is what? 4.9 times 10 to the power negative 5 volts. And then the resistance that is given is 2. That is how you would have just calculated there. That is how you would have just calculated. You now have got the induced EMF and the effective resistance. So your total current there was just going to be equal to 2.45 times 10 to the power of what? Negative 5 amps. That is the current that would be what? Moving through or else passing through the galvanometer. So that was our question paper, guys, from KZN. Thank you so much for being together. Let's actually what? Let's meet on our next coming videos to come as we continue to practice as well as to revise and prepare for our November exams. Thank you so much. I say more light and more light. Let's continue to win, guys.